Hi guys, my name is Shen. I'm a second year biomedical engineering student, and today I'm going to be working through a statics problem with you guys. So here we have homework number 9, problem 2, and we're going to work on a space truss problem. So first, what I usually like to do when I start with this is decide which point to go and find everything. So in this case, I would choose point G and point E because that will give you all the trusses with the least amount of work. Next, I usually like putting the points next to the letters. So let's start with D. So D is going to be 0, 0, -2, 4. C will be 0, 2, 4. And G will be 4, 0, and 4. E will be 4, 0, 0. And A will be 0, -2, and 0. And B will be 0, 2, and 0. All right, that should be all of them. Let me just double check that I have them all correctly. All right. Next, I choose which joint to start my free body diagram. And in this situation, I'm going to start with point G because that has forces that we already know. So I'm going to draw a free body diagram, label it G, and I will draw the forces we know. And then with the remaining, I usually just like to draw them in tension first. And then if they come out negative, then I'll switch them to the compression. Alright, that should be all of them for now. And let's start writing out the forces. So we know TGD is equal to the force, and we're going to do the unitized vector and find point GD, or the vector GD. So that will be GD there, so it'll be 0 minus 4, which is -4. Then it'll be -2 minus 0, which is just -2. And 4 minus 4, which is 0. And we're going to deunitize that vector. I usually just use a force program, then write the values. That'll be -0.894, -0.447, and 0. And for TGC, we're going to do the same thing where we unitize vector. Although in this case, we know that they're both the same point, just one number is negative. So we could just either copy it all down and just change one of the negatives, or we could just read the whole process. I'll just read the whole process so you can understand. So then TGC would be 0 minus 4, which is negative 4. Then it'll be 2 minus 0, which is just 2, and then 0. And then you find the size vector, which will be negative 0.894, positive 0.447, and 0. Now we'll find TGE. Right. So TGE, we know we're given, we just know that it goes straight down. So there's no X and Y component. So we can just go and write TGE 0, 0. And we know it goes down, so just write negative 1 in the Z direction. Now we have the knowns. So we know the force of 4 is equal to, the 4 only moves in the Y direction, and it moves in the negative Y direction. So it'd be 0, negative 4, 0. And as for the force of 6 kilonewtons, that'll be 0, 0, negative 6, since it moves in the Z direction downwards. And now we're going to do the equations of equilibrium. So I usually like to start where I write all the f of x, and then f of y, and then f of z all together. So just start with f of x. So I start with TGD times, I do TGD times negative 0.894, because that's the x for TGD, and negative 0.894 times TGD. Then we do TGC, the x for that, which is also negative 0.894. TGC. Oh, I just realized. Bad. And then we have TGE. So that is going to be 0. So it'll just be plus 0 TGE. And then E plus 4 or plus 0 equals to 0. Let me just fix this. Right. Sigma f of x equals to 0. Now we're going to do sigma f of y equals 0. We're going to look at the y components. So negative 0.447 times TGD minus or plus 0.447 times TGC, then plus 0 times TGE minus 4 equals to 0. Then we'll do f of z equals to 0. That'll be 0 TGD plus 0 TGC, and then minus 1 TGE, then minus 6 equals to 0. And the easiest way to solve this is just using a calculator, making a matrix, a 3x4 matrix, and then using RREF. So RREF, our matrix will include, you'll just basically write every number across. So this number, this number, this number across. And then I'll be moving the -4 and -6 to the other side. But it'll be easier. Okay, so our matrix will have -0.894, -0.894, then 0, and -0.447, 0.447, then 0, then 0, 0, -1. That'll equal to 0, and I'm going to move to the -4 to the other side, so it'll be +4, and then -6 to the other side, so it'll be +6. And then I will just plug that into my calculator. We'll be making a 3x4 matrix. And RREF of that matrix. Right? So for TGD, I got -4.474. Since it says it's negative, I originally drew it in tension. So that means if it's negative, it comes out as compression. So we'll do 4.474 kilonewtons, and that'll be in compression. For TGC, I got the same exact value, but it was positive, so this one is in tension. This one will have a little T next to it. And then TGE, that will equal to -6 kilonewtons, which will be compression. And since it is negative, now we have our values. Right, and then in the free body diagram I just drew up here, I'm going to change what we know is compression. So TGD, I'm just going to change the arrow so that it's going to be pointing around that way, the opposite direction. And then TGE is also compression, so we're just going to use that. Oh, and then do it this way. And then we'll move on to point E. And now that we found point GE, that'll be the same value. And we can find the rest of the truss. E. Let's draw the free body diagram. And we know that GE is actually compression. So instead of it going up, it's going to be going down. Cool. Point E, and then GE. We know that there is a point EB. And there is a point EA. And then there is a point E. Sorry, my free body diagram is a little messy. All right. So that's what we have so far. I'm gonna move this down slightly. Okay. So now we're just gonna do the same thing when we find the vectors. We know that PE equals to the vector times Mital's vector, and e to d. So let's see. E to d is going to be 0 minus 4, which is negative 4. We're going to do negative 2 minus 0, which is negative 2. And then 4 minus 0, which is 4. And we're going to unitize that. So that'll be TED times right? So we got negative 0.667, negative 0.333, and then 0.667. As for next, we'll do TEA. So TEA vector times a unitized vector, which will be 0 minus 4, which is negative 4. And it'll be negative 2 minus 0, which is negative 2. And then it will be 0 minus 0. And that'll be TEA. Unitize vector of that. All right, and then I got negative 0.894, negative 0.447, and 0. Then I'll be finding TED times the unitized vector of that, which is going to be 0 minus 4, which is negative 4, 2 minus 0, which is 2, and 0. So that'll be TED. That'll be negative 0.894, positive 0.447, and 0. All right, and then we do the same thing as before where we do sigma x equals to 0, sigma y, f of y equals to 0, and sigma f of z. Oh, sorry, I forgot. I completely forgot to write TG. Let me write that now. So we calculated that earlier, and we know that TGE only goes down in the z direction. So x and y is 0, so it'd be 0, comma 0, comma 6. Negative 6, sorry. Since we know it's going down. All right. Now we can go find sigma f of x equals to 0. Here. So we know that negative 0.667 times TED minus 0.894 times TEA minus 0.894 times TED minus 0 equals to 0. We know f of y equals to 0. So negative 0.333 times TED minus 0.447 times TEA, then plus 0.447 times TE minus 0 or 0 equals to 0. Sigma f of y or f of z equals to 0. So we know 0.667 TED plus 0 TEA plus 0 TEB minus 6 equals to 0. And we'll do the same thing where we use REF to find the solutions. Our matrix will look like this. So it'll be negative 0.667, negative 8.4, negative 8.4, and that will be 0 to the side, negative 0.333, negative 0.447, positive 0.447, 0.667, 0, 0. TET, TEA, TEB. So make sure when you're making your matrix, you read across from left to right. And you also want to make sure that all of these, when you're making the matrix, line up and you put them in the same order. So this is like 1, 2, 3. So it'll be 1, 2, 3. You want to make sure that they're in the right order. If they are not in the right order, you will not get the same answer. Same with if this is not in the same order, then as like the rest of the line, then you will not get the same answer. You just got to make sure that you keep everything in line. So that will equal to 0, 0, 6, and I got that because you just moved the 6 from the negative 6 over here to the other side, and that's positive 6. And then you just calculate that in your calculator. So again, it'll be a 3 by 4 matrix. Let's see, so for TED, I got 8.996. And I got positive, which means it's in tension, because we originally already had it in tension, or drew it in tension, the free body diagram. And then for TEA, I got negative 6.706, which means it's in compression. Compression. And then I got 0.005 for TEB. That was negative, so that'll also be in compression. We're gonna go and fix that on our free body diagram so that the arrows are facing the same way. So it's TEA and TEB. Okay, so that way, I'll be going that way. All right. And then now I'm gonna write everything in our picture. So TGD, which was 4.474. That one was in compression. Then TGC, which was 4.4, but intention. And then we're going to do TGE, which was 6 kilonewtons. And compression as well. Then we'll do TEB there, and that was 2.996 in tension. TEA 6.706. And that is in compression. And then TEB, which is 0.005, which is in compression as well. Now highlight all of our answers. Make it easier to read. All right, 2, 3, 4, 5, 6, and there we have it. Question number 2 is solved. I hope this made sense, and thank you for listening.